Okay, so I am here today, but I have to grade Academy entrance tests. So I'm actually downstairs, but I'm in the building. So you really should be able to go through this handout with just following the directions, but just in case you're having trouble, I thought I would make this video and kind of walk through it with you. You're going to need this handout and you're going to need your graphing calculator. Obviously your device to watch and listen to this video. Okay, so the first thing it asks you to do is to sketch the graph. So you should know how to do that. You guys have already practiced that and taken a quiz. So you would start off by finding your zeros. It's already factored. And because you have x with an even exponent, that would be a tangent, but everything else would be crosses. There are 2, 3, 4, 5 x's. It's fifth degree. That makes it odd. And all the x's are positive. So odd positive goes down on the left, up on the right. So let's get a sketch done. We need to go to -4 on the x-axis and just 1 on the positive x-axis. Okay, so I'm going to put my points on the graph. 0, -3, +1, -4. And then I know the end behavior, so most of it's crosses. I just want to make sure I'm tangent at 0. So I'm going to start with down on the left. And I'm going to cross, turn, touch and turn for tangent, and cross again. Okay, so there's my sketch. Okay, now it says to go to your graphing calculator, enter this function that you just sketched into y equals, and to adjust the window as mentioned right here. So I'm going to go to my calculator on my computer. Okay, so first of all, you want to go to y equals, clear whatever out, that you might have there. Make sure none of these plots are highlighted. That means they're on, and that's not going to work well with what we're trying to do. So if any of your plots are highlighted, then you need to go up, hit enter, and now that turned it on. So go up, hit enter, and now I've turned it off. Okay, so I'm going to type that in there. X squared times x plus 3 times x minus 1. If you guys can hear the planes flying across right now. Okay, and then once you type that in there, you also want to adjust your window. So hit window, and it says your x min is -5, your x max is 2. As long as your numbers aren't too outrageous, I would just keep your scale at 1. The y min is -35. And your y max is 25. And again, keep the scale at 1. All right, so I'm going to hit graph. So when you're adjusting your window, obviously I gave you the window this time, but that's part of doing this is you'll put the function in there and then you'll have to play around with the window until you can see every turn on this curve. Okay, so sometimes the turns are going to happen at really big or really small y values, and you're just going to have to make sure that you adjust the y min and the y max until you can see every single turn. Okay, so the graph that I originally sketched is pretty good as far as, how high and low these turns are. And what we're doing is we're finding all of what we call a relative max and a relative minimum and intervals of increasing and decreasing. So every turn, there's 4 here, is either a relative max or a relative min. Think about climbing, going up and down mountains or something. Your relative maxes would be at the top of a mountain or hill. Your relative mins would be at the bottom of the valley. Okay, so as you go from left to right, this would be a relative max, then a relative minimum. A tangent is still a turn, and this would still be a relative maximum, and then this is another turn that would be a relative minimum. Okay, and then we're going to also find intervals of increasing and decreasing. Think about if you had a little guy here on the left end, and he was going to hike along this polynomial trail. Every piece of the trail, he'd either be going up or going down. Going up is increasing, going down is decreasing. So from left to right, you'd start at -infinity, Person's increasing until it gets to this turn, now decreasing until this turn, now increasing until this turn, decreasing until this turn, and then increasing again. So from turn to turn, going left to right, every section of the graph is either an increase or a decrease. And every turn changes that from increase to decrease, okay? All right, so we are going to basically use our calculator to find the different parts. So it says, use your calculator to find the coordinates of the highest point on the curve in quadrant 2. Remember, the quadrants start in the upper right-hand corner and go counterclockwise. So this is 1, 2, 3, 4. So we want to find the highest point in quadrant 2. That would be right here. So we want to do second, trace, maximum, because that's what that point is. And you're going to answer the questions. When it says left bound, just move your cursor anywhere to the left of the point you're trying to find. Hit enter. Then it says right bound, move your cursor anywhere to the right of the point you're trying to find. Hit enter. Should mark it off, so the point I'm trying to find should be between these arrows and these lines. When it says guess, just hit enter. And this is the point that you want to write down. So in number 4, where it says highest point in quad 2, you want to write down this ordered pair. It says round to the thousandths place. That's 3 decimal places. So you're going to write down the ordered pair negative 3.593, comma 14.311. Okay, so as you follow along, it says this point corresponds to a relative max for this polynomial. We record it as the y-coordinate of the ordered pair at the x-coordinate. Now, I do recommend that as you go along, I would, and this is for all these problems, I would, as you find these points, I would go ahead and mark them on your graph because you want to be able to go back to these values. So this is a relative maximum, and according to the calculator, it was at negative 3.593, comma 14.311. Highest point, negative 3.593, 14.311. Okay, the way that we write a relative maximum or a relative minimum is we write the y-coordinate at the x-coordinate. So max and min is about height, and y would be the variable that's about height. The y-axis goes up and down. That's height. So you're going to write the y-coordinate at x equals the x-coordinate. So it tells us how high it goes in quadrant 2 and at what x value that occurs. Every time I ask you for relative max, relative min, you want to figure out the ordered pair, but you actually want to give me the answer, the y-coordinate at the x-coordinate. Okay? All right, so then the next thing says to use your calculator to find the coordinates of the lowest point in quadrant 3. So we're going to find this point right now. Okay, so let's go back to our calculator. And you're going to do second, trace, minimum. Answer the questions. You need some point to the left of that minimum. Go to the right of the turn. Hit enter instead of guess. And record that point. So you're going to record negative 1.907, comma, negative 24.184. Okay, so let's do that. All right, so again, I would get in the habit of labeling it on your graph. So if you need to go back to those numbers, because you're going to use these numbers for both relative max and relative min and intervals of decreasing and decreasing. So it's good to have them there so you can grab the numbers as you need them. So the lowest point in quadrant 3 that we just recorded, but that's a relative minimum. So remember, we want to actually state that as our relative minimum by writing the y-coordinate at x equals the x-coordinate. Okay. Use your calculator to find and label the coordinates of the lowest point in quadrant 4. That's going to be right here. Okay, so we do that. So second trace, remember it's another minimum, so we're going to do minimum again. We're going over there to quadrant 4. We're skipping over a tangent that's happening at the origin. That is a turn. It is a relative max, so we're going to skip that for the moment. Okay, so left of that turn in quadrant 4, right quadrant 4. Guess we do enter. So we're going to go record that minimum at 0.700, comma, negative 2.556. So let's do that. Again, do it on your graph. Attention to detail pays off in the end. And these can kind of take a few minutes to do each problem, so shouldn't be giving you too many of them like on a test or a quiz. Okay, so we've got the ordered pair recorded on our graph, but remember the way we're actually going to answer for the relative minimum is the y-coordinate at the x-coordinate. Okay, then it says record and label the coordinates where the curve is tangent. We shouldn't need to find that on our calculator because we already sketched it. So we should already know that it's 0, 0. And if you go back up to your graph, that's a relative maximum because you are hitting the top of a peak there. So this is also a turn. It is the point of tangency that we knew from our sketching. And so this is a relative maximum. The maximum is 0 at x equals 0. Okay, so when you're finding relative max and relative mins, you need to find the coordinates of every single turn. Tangents are turns. Points of inflection are not. Remember, points of inflection are you're acting like you're going to turn and then you keep going in the same direction. So you do need to find the coordinates of your tangents, but not your points of inflection. Okay, that is not a turn or a change in direction. Now, let's just for fun, let's go to our calculator and see if we can get the calculator to give us that tangent that happened at the origin. Like I said, you should have already known it was there, but sometimes, you know, you could be a little OCD and be like, oh, I want to prove it. Okay, so second trace maximum. Point to the left of that origin, point to the right. Hit enter for guess. Okay, so this is the reason I actually wanted to go ahead and do it on the calculator. If you're trying to find one of these points on the calculator, anytime you get kind of a complicated looking number with E in it, it actually means 0. I don't know why the calculator doesn't just say 0, 0, but that's what it means. Okay, so don't let that confuse you. If it says something with E, just write down 0 instead. Okay. So I had already written down 0, but just want to make sure. Okay, complicated number with E really just means 0 for our calculator. All right, so let's keep going on the back. Now we're going to do increasing and decreasing. On what intervals does the curve increase? On what intervals does the curve decrease? Think about traveling along the curve from left, which is negative infinity, to right, which is positive infinity. Use interval notation and the x-coordinates of each turning point on the graph. That's important. Remember that tangents count as turns. Okay, so if I move back to my graph, so every section from left to right. So if I put the little guy here, he's either going up or going down. So this would count as an increase. Then you turn. Now you're decreasing. Turn, increase. That doesn't really look like increase, does it? Then this is a little decrease, and then you turn again, and we're back to increase. So I've got increasing interval, decreasing interval, increasing interval, decreasing interval, increasing interval. They're always going to alternate because they're around turns, and every time you turn, you've changed direction, which means you've changed increasing, decreasing. All right, so we want to write down the intervals of increase and decrease. So if you look at your graph, it's starting on the left end from negative infinity. It's starting with an increase, and we want to use the x-coordinate. So to the x-coordinate of the first turn is negative 1.2. Oops, sorry. It's like my first big mistake. It would be negative infinity to negative 3.593. Okay, that is the x-coordinate on that first turn. Then this is a decreasing section, and that's gonna go from this x to this x. Okay, and you don't have to go in order. You can just do all the increasing and all the decreasing, or you can alternate. So negative infinity to negative 3.593, that's the first increase. Negative 3.593 to negative 1.907, that's the first decrease. So then back to increase, negative 1.907 to 0, back to decrease, 0 to 0.700, and then you end with an increase on this graph, and that should end at infinity. So notice how it alternated. Start with negative infinity, whether that's an increasing section or a decreasing section, go to the first x turn, then you switch to the other thing and be the same x to the next x turn, and then use that same x on the other part. And it should alternate back and forth to 0, and then 0, and then 0.7 to 0.7. So you want to alternate back and forth. The big thing is to make sure you're using the x coordinates, okay, because we're traveling from left to right, and x's go from left to right. So you do not use the y coordinates at all here. Okay, so what I want you to do now is I want you to pause the video, work with a partner or by yourself, whichever you prefer, and work on these two examples. Remember, you're going to have to play around with your window. You get it sketched because you know how to sketch polynomials, but then you're going to play around with your window until you can see every single turn. Then you want to use a calculator to find the coordinates of every single turn, record them on your graph, and then answer the questions. Okay, so pause the video, and when you've done that, then come back and you can check your work. Okay, I hope this was valuable and that my voice didn't sound too crazy. Okay, so here are the answers to those two examples. Pretty sure I got all the points right. I double checked from my key, and I double checked on my calculator. So you get your sketch, get all those points labeled. This one has just 3 turns. One of them's a tangent that you should already known about. And you go from increase to decrease to increase to decrease. And this one has 3 turns as well, one of them being a tangent that you should have known about from your sketch. It goes decrease, increase, decrease, increase. Okay, so if you didn't get some of the answers right, then go back and look again on your calculator or ask a classmate to help you. And once you get all this done, and then you have another handout that is practice that has 9 problems, and that's what you should work on for the rest of the class, and it's what I will check for homework next class. Thanks.